And okay, we will start with a brief introduction to the European SSbD framework. But first of all, let me briefly introduce ITENE, which is a research center located in Paterna, Valencia, in the east coast of Spain. We have set up as private Spanish non-profit association, and our mission is to generate scientific and technological knowledge that we transfer to companies through different R&D and innovation actions and projects, also through consultancy testing and training services. We collaborate in R&D projects with more than 400 companies, and we develop our research and development activities at regional, national, and of course, European level. We are focused on four main working areas to generate this knowledge and technology. First one focus on materials and circular economy. Other one focus on packaging, sustainability, safety and design. Other one more focus on safety aspects and monitoring of the air quality and safety. And the fourth one focus on transport and logistics. So let's start. What is the context for this SSbD framework? Okay, within the European Green Deal, the European Commission aims to transform the European Union's economy for a more sustainable future, focusing on climate, biodiversity, circularity, also in human and environmental health. So the goal is to achieve or move towards a toxic-free environment, and to ensure and promote human and environmental health. So to achieve these objectives, we have the chemical strategy for sustainability that calls for a transition to a safe and sustainable by design approach for chemicals. It covers since new raw materials, new bio-based products, any kind of new materials that is under development. To be successful in this goal, it is required to have a common understanding on what are the main safety and sustainability aspects required to be considered from early stages. So with this aim, the European Commission, joined with the Joint Research Center, have been set up the SSbD framework through two different documents which are published. This framework aims to promote the safety and stability, identifying and minimizing from early stages of the innovation processes the impacts that could have at the end on human and environmental health. So addresses the safety and the sustainability of the materials, chemical product processes along this life cycle approach, including the first steps of innovation, research and development. Also, production, use and recycling can bring this objective towards a safer and a greener landscape at the European level. It consists in a 5-step methodology. The 3 first steps are related with safety aspects, focusing on properties of the materials, human health and safety aspects during processes or production, and in the final application steps. And the 4th one is focused on sustainability assessment. Then there is a 5th step focus or covering social and economic aspects. For each of these steps, we have a scoring system followed or based on a decision trees and cut-off criteria, which allow to determine and identify what are the materials or products or even the processes in where we have to pay attention to get these safer and more sustainability alternatives. So in order to cover this assessment, within the framework, there are a lot of different methodologies recommended by the European Commission to cover the safety assessment as well as the sustainability assessment. In the case of safety, we can address the hazard assessment through different methods based on bibliographic review, also experimental testing. Of course, in the case of product process, we can apply the occupational exposure monitoring methodologies. And in the case of sustainability aspects, we have several different methodologies that my colleagues are going to explain in more detail. For example, the LCA or the circularity methodologies, as well as the socio-economic impact aspects. So let's see a brief introduction of the research project.
Hello, everyone. Well, the idea of this part is to contextualize this approach of the sustainability and safe by design methodology in the PRESERVE project. Okay. So, well, PRESERVE project is a European Union funded project, which the main aim is to make more circular or to guarantee the upcycling of biopolymers and bio-based materials. To follow this main target, well, the first of all is the enhancement of the bio-based packaging properties. To achieve this, there are different technologies involved in the project, such as, for example, the barrier coatings or e-beam treatment. And also the other part, the main other part is the study of the different end-of-life processes in order to evaluate different alternatives to guarantee the circularity along of the new biopolymers and bio-based materials obtained during the project. As transversal way during all the project, also we are developing and follow the different standards and certification schemes in order to make more valuable these new materials and to address in a better way all the new developments. So, well, in this scope of the PRESERVE project, we are now with ongoing demonstrators in order to demonstrate the different new materials and the different new structures, obviously taking into account the SSbD approach during all the developments. So, well, here you have the different demonstrators that we are working on right now. Some of them are for the food packaging applications, in different formats, such as flow bags, lead films, thermoform trays, or dairy pouch and bricks. Another one are for non-food packaging applications, such as personal care or transport, in case of, well, carrier box, shopping bag, or more specifically for personal care applications such as injected jars and bottles. So, well, the idea is starting taking into account these target demonstrators. The idea in order to implement and to work through the SSbD approach is to make a starting point from the benchmark packaging structures of these target demonstrators. So now from this starting point, the methodology is going on, and the idea is that during this last year of the project, we can achieve this apply methodology through the new packaging materials developed in the PRESERVE project. So, well, with this context and the introduction of the methodology, now, well, this is also the partner. So, sorry, I'll follow this slide. Well, in order to see that the different collaborative work that we have in the project with RTOs, also users, and well, different roles that they are very important to succeed the target in the project. So well, now yes, I give the floor to my colleague Javier in order to specify a little bit more the implementation of the methodology.
So hello everyone. In this part, I'm going to try to explain how are we applying the framework to this project. In this case, I would like to first talk about why, what, and how is the sustainable by design. In this framework, we try to emphasize on designing products, process, and systems that are safe and sustainable. This is mainly done by mitigating toxicological effects and minimizing the potential exposure throughout the product life cycle. In the case of the why is because of the release of potential harmful substances that can be made by the products that we are developing. The what is the environmental impacts and possible effects on health, and how is by reducing the material toxicity. So in this case, the sustainable by design framework is being applied all throughout the project, as I said. And this is mainly done by the development and choice of the new materials in this project, then the industrial scale-up processing and products of final and the production of the final products, and then the final use phase and the end of life. So this is the process that we are following for the sustainable by design in this project, which is mainly in the first phase defining a criteria for every step that is that has been done in previous tasks. Then gathering information from the partners by communicating with them, getting information. And then we start with the analysis of the different products and chemicals that we are using. In the first step, is mainly theoretical. We are assessing the chemicals and the materials based on the ECA and CLP regulations and also on the safety data sheets of the particular materials being used. Then in the step 2, we focus on the occupational health safety. How are the workers exposed to these chemicals or materials, and if these exposed can be toxic or can be hazardous for them. Then the third step is based on the human health environmental aspects of the final application. How is the product or material that is being developed affecting the final users and environment because of the usage phase? And then in the fourth step this is based on an environmental assessment of the chemicals and materials all throughout from the production phase to the end of life. So this is the first step. Here we define 4 different levels from 0 to level 3. And we classified all the chemicals that are being used in these 4 levels. How? Well, so we can base we can use this matrix and defining, as in the framework, the chemicals in different groups, group A, group B, or group C, and then the ones that are not in any group. And then we take all the materials that are on level 0, and we try to substitute them for ones that are less toxic intrinsically. The same is being done for the level 1, and then level 2 and the level 3 are also, the level 2 is also think how can we reduce the toxic effects of the materials or chemicals being used, and then in the last level, these products are completely safe. This is being done, as I said, assessing the chemicals by the REACH and the CLP regulations. In this way, we can assess the human health, environmental hazards, and the physical hazards. we assess the chemicals used in particular, and then we proposed an alternative or a strategy in order to mitigate these effects. As you can see, this is an iterative process, which is really important because we need to make sure that by every modification or every substitution that we make on the substances, the product keeps being safe. In this manner, we can try to improve the product, the chemical or the material as much as we can. For the step 2, we are also using a matrix that has been developed by the European Union, and we also classify the products in 5 different steps in this case. This is the risk that the workers may be exposed to when using these materials. And then we classify in 2 main areas, which are level 0 and level 1, in which the materials are prioritized for modification or substitution because working with them may be hazardous or dangerous for the workers. Then we have the level 2, which is also important to reduce the risk of these materials of working with these materials. And then the level 3, level 4, which may pass the safe and sustainable by design assessment. This is being done again with the REACH and CLP regulations, then an assessment of the safety data sheet, and here is important to gather all the information that is possible from toxicological or ecotoxicological assessments, because some materials or some chemicals maybe don't have all the information available. So here is where we gather all the information experimentally. Then in this case, we establish a risk classification, and then we estimate which is the exposure of the workers to these chemicals or materials. Then with all the information gathered, we think on actions that can we take, substitution, modification, or working on the process itself by giving personal protection equipment to workers or other alternatives in order to make the process safe. In this case, also it's important to remember that it needs to be an iterative process. Then for the case of the third step, we here classify the materials on 3 different levels, from 0 to level 2, and we assess which is the amount of the exposure that the final users and the environment may be exposed to when we launch the product. In this case, we have 5 different scores in order to establish the product and the chemical in these 3 levels. And also, as told before, we evaluate the migration of the chemicals into the content in the product content into the packaging. In this case, because we are developing some packaging, then we evaluate the migration of the plastics from these products into the environment, also assessing all the migration possible in the end of life and in the usage phase, and then we think how can we improve these products in order to reduce all the migrations, all the possible exposure routes of the final products. And then in the fourth step, which will be better explained later, we have 6 different steps, 6 different levels, sorry, from 0 to level 5. And here what we are doing is giving a value to all the different aspects that are being taken into consideration in the LCA assessment. Through this, we can know if the product developed is or not sustainable, and then act in consequence of this. For example, this is an example of the weight that we are giving to the different aspects measured on the LCA assessment. And with the work from our partners from NTT and also my colleague Carla, we can give a value to all the levels that are considered on the LCA, and then as final score for the different for the product, and know if we can pass or not the product. Also, this is an iterative process as the products will be changing along the time. And now I leave the floor to Daniele. Will you share the presentation, Daniele?
Yes, I can share.
Okay.
Can you see?
Yes, it's visible. Thanks, Daniel.
Okay, good morning. Daniele Spinelli from Next Technology Technotech SIL. A few words about our organization. Next Technology Technotech is a public-private research organization founded in 1972, and we are located in Prato. So our main business is to support companies to improve their competitiveness at product and process level. So we are quite active in R&D activities related to textile development, and those starting from materials till the final products realization. Our main focus, as I said before, is related to transfer good technology from the market and try also to test and validate products for different sectors. So at the moment, our key business are related to circular approach and sustainable materials for textile applications. According to that, we are also supporting companies to reach new textile technologies, starting from raw materials till the final products. We are quite involved on modification of material surface and to functionalization of materials. We are also cooperating with other industrial sector like for different composites application for packaging, automotive, furniture, and building sector. We are also promoting a sustainable and circular solution, taking into account also possible applications for upcycling or downcycling. And also we are supporting product development and European consortium through environmental life cycle assessment monitoring of the different value chain. Say that we are also managing the Tuscany Fashion Cluster in Italy that is consistent around 400 members that are mainly companies in the fashion sector of our region, and we try to have a sort of to establish new collaboration between these members. We have also a lab to perform a validation of materials, starting from leather and textile product, but also for composites that are applied for transport sector. We have different collaboration in terms of international partnership. So we are promoting collaboration between industrial value chains. So here you can see some of the projects that are managed by our group. And we try also to support the internationalization of European SMEs and try to grow new opportunities and new market and so new business for them. In few words, we are also trying to accelerate the transition, a green and a digital transition of companies. From the technical group and particularly the division which I'm part, we are also involved in projects related to circular economy and also a green economy, as we are also part of bio-based industry consortium. So here you can see that we have different projects at the moment that are ongoing with a key focus on these areas that I have mentioned before. Going into details about the environmental life cycle assessment methodology, we can say that this methodology is a decision-making support. It means that performing this type of evaluation will support the design of new products, mainly taking into account the environmental footprint of a new products. And this is also important to solve some bottlenecks that at the moment are limiting some products in terms of market penetration. So the methodology is well known and also applied for different industrial sector. And today I see that also not only for European project, but also in other collaboration that also from our side we have with private company, it's important to evaluate the environmental footprint of products and processes. So the methodology is divided in 4 steps. We have a first step in which usually we are defining the goal and scope definition. Mainly here, the idea is to identify a specific product and system boundaries that will be part of the analysis. The step 2 is related to life cycle inventory. It is a step to collect data or also to define a calculation procedure to quantify all the relevant inputs for a specific production steps, and also considering co-products and waste and also output from the product system itself. The step 3 is related to life cycle impact assessment, and in which step we are linking the inventory data with the environmental impact categories and different indicators. So usually this part is made using a specific software and data elaboration. And the step 4 is life cycle interpretation. It means that in this step we should interpret by reporting and all the data and try to provide consistent consideration of the analysis. So in terms of support to the eco-design, we should clarify 3 main concepts. First of all, what is sustainable design? Sustainable design is a design that links the reduction of social, environmental, and economic impact of a specific product, because the main aim is to minimize these impacts as much as possible. In practice, the idea is to reduce this impact along every step of life cycle of a specific products, and try also to reduce as much as possible the waste phase. So here we should also consider, for example, and analyze the environmental impact on materials, and so in terms of which impact our materials we realized, and which processes could be optimized. So we need to address these points. Eco-design. Eco-design is mainly focusing on the reduction of environmental impact in each step, and try also to have to reduce the value of the impact categories for each product's life cycle. It means that it's important to analyze process and materials and try to improve this value, so reduce, starting from the design. Now this practice is also well known, and usually to propose a new product on the market, now we are starting from the eco-design approach. So it means that, for example, we should take care also of the reduction of weight or the size of the number of materials, because we should also think to reduce the impact of each production step. This part of eco-design is also connected to a circular design, because we need also to have products that are not creating new wastes or pollution. What they should also analyze how improve the circularity of our approach. It means to reduce waste and pollution during their product's life cycle, but also try to ensure that we could reach a decrease of the impact by the end life. And so the take care of the end of life of our products is also important. So not only taking care of the impact generated during the production, the life, but also its end of life. So as said before, usually the approach that we could follow through the LCA is to analyze each step in the manufacturing value chain, try to identify all the inputs and outputs. And we can also have different approaches. For example, I can analyze my products from cradle to gate, or from cradle to grave, if I'm also considering the use phase and specifically the end of life. So usually we start to collect data. So here you can see just a sort of example of data templates that could be prepared for a specific value chain, and try also to collect for each manufacturing phase all the inputs and output materials. And in most of the cases, we are also taking care not only to the processes, but also for the transportation of materials. When we have managed this data, usually we are including this data in the software. So there are different software like CIMAPRO or GEBI or OpenLCA now that could be used to manage this data, and also mainly we are replicated what we have done in terms of flow sheet in the software. And so finally, we can calculate the impact assessment of a specific product. It means to translate all the inventory data in different environmental impact categories that are connected to different environmental impact methods. So here you can see just a sort of example with RECIP methodology that is also quite well known in Europe. So each impact categories is referred to the functional unit. So if, for example, you have an estimation of a global warming effect, you could consider that you could have a data in terms of kilogram of carbon dioxide emitted for the functional unit. That could be 1 kilogram of product, so 1 meter of textile, or I don't know, 1,000 of pieces of a specific products. So this part was related to environmental point of view, but there is also a part related to the cost estimation. Mainly here, the idea is quite usually will be conducted in parallel to the LCA. And in this life cycle cost estimation, we will usually we are developing a cost identification and try to also to identify a cost benefit approach. So also usually we start from the inventory data that we have performed for the LCA, and we try to estimate all the costs related to the input, output materials, or different services, or labor cost, or maintenance cost. So related to facilities, for example. So we are considering different approach. So for the life cycle costing analysis, we can also use direct cost or also indirect cost. So As I said before, when we are considering acquisition costs, cost of use, maintenance, and end of life, mainly are related to direct costs. But we can also consider the indirect costs, because indirect costs are costs that are not directly related to the users of the products, but are costs related to environmental externalities of the products. It means that the main goal is to translate in a monetary value all the environmental impacts that has been generated by the environmental impact characterization, and this could be considered a sort of indirect cost. Another point that is also usually considered is the part related to eco cost. Eco costs are also part of cost of environmental burden of the products on the basis to prevent that burden. And also here the aim is to contabilize the costs that should be made to reduce the environmental pollution or material depletion that has been generated during the production of a specific product. And also here we can convert the environmental categories in specific equivalent monetary value. The last part is related to the social impact estimation. Social life cycle assessment is a method that could be used to assess the social and sociological aspects of a product, just to identify the positive or also negative impact among a product life cycle. So usually this approach has a different targeted end audience, like worker, consumer, or people from local community, society, and also the value chain actors. And usually we are creating a different online survey to check what is the impact of a specific innovation through this different target audience. So as we are also performing in a Preserve project, we are continuous monitoring what is the social perception pushing in the market new materials that are sure more sustainable. Or sure you can see that most of the people could be interested to accept a new bio-based material, but the cost it could be still a problem. So we are trying to investigate what could be the social perception according to the new products development. So say that all these aspects are complementary with SSbD approach that is also involved in the development of sustainable chemicals and materials, also to prevent harm to human health and both to the environment, try to have a sort of green and circular approach that are compliant with a sustainable science, but also all the sustainable development goals that has been addressed at European level and also according to the European Green Deal. And that's all from my side.
Thank you very much, Daniele. I think that we will take questions at the very end all together, and then we continue with our agenda.
Okay.
I think Carla has to share the screen.
Yeah, I will share again my screen. Just a second.
If you enter into full mode, then presentation mode.
I didn't see the
Let's see it. Just a second.
If you go down into the bar,
Yeah,
Yeah, I think it's that.
yes, but we cannot see the. I think maybe we have to stop sharing this again. Because we cannot see the full screen, so I cannot select. No. No se ve. Mm. No.
sorry about the glitch, everyone. This is our usual fight with technology. As I can see, there's you can if you can go to the left now, maybe I can guide you. If you go to the bottom to the right, because I can see your mouse.
But we are out of the screen right now.
Yes, because we
You're
can
out of
see
the
at the bottom of the screen. Yes.
Wait.
Otherwise, you can also go
Okay.
up to the left.
I think we got it.
Yes, yes, perfect.
Okay.
Thank you.
Yeah, sorry for this. No, se va a salir. Just a second. Okay, now, sorry about this.
Perfect, thank you, Carla.
But now I see the. Okay. Okay, now. Oh, okay. So, well, another step of this framework is also analyze the circularity of the product. So, which is very aligned with the LCA and SEC that Daniel just explained. So, the circular economy, just starting with the concept, is a model of production and consumption which involves sharing, leasing, reusing, repairing, and refurbishing and recycling the existing materials and products as long as possible. So in this way, we are extending the life cycle of the products. So it implies reducing waste to a minimum. In this way, we are also creating further value, and this is a departure from the traditional linear economic model, which is based on take, make, consume, throw away pattern. So here you can see, well, the different steps that we have in Preserve. Okay, so we have the identification of opportunities for circular value capture, the circular KPI assessment, and also the evaluation of the circularity scenarios. So the first step includes the searching of technical, economic, social, and environmental opportunities that allows promoting a circularity approach of materials and related packaging products. Then we move to the circular KPI assessment. So we have here to select appropriate circularity economy indicators or environmental indicators in order to define how circular the material flows are. And also we can select complementary indicators that will allow addressing additional impacts and risks that can be considered. Also, the last step will be the analysis of the potential scenarios that can improve circularity. So in the first step, I was commenting about the identification of opportunities for circular value capture. So here we have the result framework, which is developed by Arup and Ellen MacArthur Foundation. So the result framework is the acronym of regenerate, which is a shift to renewable energy and materials. to share, so share assets such as cars or rooms or reuse or second-hand items. Then optimize, so increase the performance or efficiency of a product or remove waste in a production and supply chain. Loop and well, also remanufacture products or components, recycle materials, and virtualize, which is dematerialize directly, or ITENE, which is replace all with advanced non-renewable materials on apply new technologies. Okay, so the second step is the identification of circular KPIs. So one of the KPIs that, this is KPI, which is the Material Circularity Indicator, is extracted from the Ellen MacArthur Foundation. So this indicator measures to the extent to which linear flow has been minimized and restorative flow maximized for its components materials, and how long and intensely it is used compared to a similar industry average product. So essentially a combination of three characteristics: the mass of the virgin raw material used in manufacture, the mass of unrecoverable waste that it is attributed to the product, and the utility factor, so that accounts for the length and intensity of the product's use. So this is the result should be between 0 and 1. So we have a result that is 0. This is a linear, it can be considered a fully linear product. And on the other hand, any product that contains no virgin feedstock and it's completely collected for recycling or component reuse, and where the recycling efficiency is 100%, it can be considered a fully circular product. So here our material circularity indicator would be 1. So in practice, products will be somewhere between these two extremes, and this will measure the level of circularity in the range of 0 and 1. Here I have included the preliminary, the circular indicators that we have selected for preserve. Apart from the material circularity indicator, we can also align this assessment with the LCA. So we have selected the carbon footprint. So it would be the kilograms of CO2 per functional unit, so per packet. Also it's aligned with the LCC. So it will be the euros per functional unit. Also, we can include the mass. So we can say that if the product has a lower weight, will be better. We could say that. Or the water scarcity, also aligned with the LCA, or an eco-design indicator. So in this example, you can see that we have we made a comparison between the product that is being developed within Preserve and the baseline product, which will be the benchmark. And in this example, we said that a score of 1 is best performance and a 0 would be the worst performance. So we can do like this kind of graphic in order to show how we are improving in circularity. So now I leave this is for the circularity. Now I leave the floor to my colleague Arantxa.
Hi again. We have achieved the final part of this training. So having seen the details of each of the aspects covered by the SSbD framework, we will end by summarizing the main important aspects. So from the implementation of the different steps, we can identify for each of them at the innovation process which are the critical aspects in terms of safety and sustainability. So this early identification enables to make decisions on the basis of, for example, substitution of raw materials, as my colleague Javi has explained. Of course, for modification and optimization of processes to minimize the exposure for workers, for example, where they are handling the critical materials, or even in the use phase. So as final result, we obtain a scoring result for each of these steps. In the case of, for example, this one step focus on hazard assessment, we can have this primary result. Then for the step 2, 3, 4, and so on. In the case of LCA, that as Daniel has explained, we can establish the final result in terms of percentage of improvement, covering the products and materials developed in Preserve projects. So here we have the approach performed or carried out in terms of SSbD assessment within Preserve. We have been done this evaluation of safety and sustainability aspects in 2 different stages. First one, which has been focused on the codings developed within the project and also benchmark products that are the current alternatives. This first step has been, of course, done. We have been analyzing the safety, performing experimental testing, using human cell lines, also bioassays or even mesocosms, applying the LCA and social LCA and all the circularity aspects that my colleague Carla has just explained. And the second phase, which is being carried out right now, is focused on assess the safety and stability for the demonstrators, the final demonstrators developed. So, well, the comparison between these 2 different results coming from these 2 phases will allow us to establish the degree of progress of the improvements in terms of safety and sustainability that we can address with the developments within Preserve, and try to validate or establish the alignment with the KPIs which have been defined in the previous stages of the project. So I think this is more or less the overall view about the SSbD framework, different steps that the framework is covering, and the methodologies that we are applying to cover and to implement the different stages. Of course, this is an open question right now. For sure, the European Commission, as well as the Joint Research Center, will come with new recommendations, more detailed explanations, and methodologies to be applied just to cover more appropriate the different aspects. This is just the beginning of this kind of work, so we are just making the basis of that. And in terms of materials and the landscape, the future landscape in the European level, well, at the end, since we have to be aligned with the overall objectives of sustainability and zero pollution, this will be like a very useful tool to address these results from early stages. It could be covered or be applied to every kind of different materials, chemicals, with bio-based origin or the synthesis. It's like have a very wide approach, so it could be very, very useful in the near future. And yes, now is the time to answer the questions. If you have any doubt, comment, or something like that. Also, once you have received the presentation, we will add our emails in case you want to raise any kind of questions by email. So we will update the presentation for Estela to listen to you. Estela, you're muted.
Yes, sorry. Thank you very much, everyone. Thank you very much. Of course, the ITENE team, Arantxa, Javier, Carla, Teresa, and Daniele from NTT. Thank you very much. Now it's the time for some questions. We have roughly 5 minutes. But yeah, I mean, it was really, really, really interesting, really full. I invite then people to raise their hand if they have questions. You can also, as I wrote before, leave any question there in the chat. If you're feeling a bit shy, that's also fine. Let me see the gallery if we have any hand raised or comment. Otherwise, I have. Let me see. I don't see anything right now. Well, then, thank you. You allow me to ask actually something that is very important for for the future of the industry. For example, I, as representative of European Bioplastics, we are a membership organization, and we have several companies that work on bioplastics, and the circularity, for example, is key. So how can a company improve the material circularity indicator of a product, for example? That's something that it's important to know.
Sorry. Yes, I think a company can improve, the circularity of a product if it is on the raw materials. For instance, it uses recycled materials, or if when we eco-design our product, it can be fully recycled. So it's a step that should be taken into account at the beginning, just as for from the beginning to the end, covering all the stages. So when we throw our product, it can be recycled. So this way we would improve the circularity.
Thanks, Carla. Thank you very much.
Welcome.
I think a last question, because it's about to be 11, but this is also something that maybe many of the people here that work on other different type of materials. Is the sustainable and safe by design valid for any type of material, actually?
Yes, of course. At the end, the goal is to ensure that the new products and processes could be safer than the current alternatives. So depending on the materials you are handling, maybe you have to address a different methodology, because there is some differences. For example, if we are talking about nanomaterials, in terms of hazard assessment for intrinsic properties, even the occupational exposure monitoring is different than, for example, in raw materials or materials in no nanometer scale. So there are many differences between kind of materials. Of course, in the case of bioplastics, you should consider other aspects, for example, biodegradability, compostability, and so on. In the case of how can these materials affect aquatic ecosystems, for instance. So depending on the materials, you have to pick or select one methodology or another in each of the steps. But since the approach is so wider, you can address and apply in different ways depending on the materials. Actually, maybe some of you which are involved in new proposals and so on already know that SSbD framework is a requirement for any kind of new development in terms of coatings, bio-based materials, for example, also to alternatives like PFAS, microplastics, and so on. So it is totally open.
Thank you, Arantxa. Thank you very much. Indeed, I think probably we all know by now the importance of the SSbD framework and its implementation, and the importance that the Commission is giving to it. You also mentioned, and now I'm taking the chance to promote our next training, actually, the Preserve training on biodegradation. You mentioned that, for example, in the case of certain materials, for example, bioplastics is very crucial to actually take into account biodegradation. We have a Preserve training on the 24th of May, also at 10 in the morning, on biodegradation, one concept, many environments, that will be provided by Normic OWS. You can check everything on Preserve, social media, website, etc. With this, I really want to thank you again, ITENE, for such a wonderful training, and NTT, Daniele. It was really interesting. It was really profound and really explanatory. And as you mentioned, Arantxa, everything will be, the presentation will be shared on our website, will be shared with you in due time, and the recording as well on our YouTube channel. And of course, if you have any questions, you can always write to the Preserve info or the contacts that might be in the presentation, and then we will be happily taking your questions and exchanging with you. So thank you very much, everyone. And I hope you have a very nice week and Labor Day free tomorrow. Everyone, hopefully you all are free on leave tomorrow, and see you soon.
Okay, thank you very much.
Thank you.
Bye.
Bye.
Thank you. Bye bye.
Thank you. Bye-bye.